Solve the equation 4 to the power of x minus 15 times 2 to the power of x is equal to 16 for x. So what we need to do is see that there is several bases raised to the power of x, and it would be most convenient if we could write all of those with the same base. So 4 to the power of x is the same as 2 to the power of 2 to the power of x, and then we have minus 15 times 2 to the power of x is equal to 16. Now, this is starting to look a little bit like a quadratic hidden within an exponential. So to simplify things, we're going to let a equal 2 to the power of x. And that means we can rewrite this. So that means that 2 to the power of 2x now is the same as a squared. Then we have minus 15 times a, and we can write it as minus 16 equals 0. So the general way that we solve quadratics is to factorize them and use the null factor law. So this can then be written in factorized form, so it's still going to equal 0, and we can have a minus 16 and a plus 1 as the factorized form. So using the null factor law, that says that a minus 16 could equal 0, so therefore a equals 16, or we could have a plus 1 equals 0, therefore a equals negative 1. However, back up here we can see that a is just 2 to the power of x, so we can now substitute that back in. And that means that we are in fact solving 2 to the power of x is equal to 16, or we're solving the equation 2 to the power of x equals negative 1. So for the first equation, 2 to the power of x equals 16 can be written as 2 to the power of x is equal to 2 to the power of 4, because 2, 4, 8, 16, so 2 to the power of 4 equals 16. So because we now have the same base, we can simply equate the powers, which means that x is equal to 4. For our other option, we have 2 to the power of x is equal to negative 1. And now there's no number that we can raise 2 to the power of that will give a negative number. So that means that there is no solution. For now, I'll provide a graphical interpretation of why that's the case. So if this is x and this is y, then the equation y equals 2 to the power of x is this line here. Then if we graph y equals negative 1, so if this is y equals negative 1, you can see that there's no intersection between those two graphs. And that's because there's an asymptote that lies along this line, and that is at y equals 0. So y equals 2 to the power of x is never negative. Therefore, the only solution we have to this equation is x equals 4.